Okay guys, just now we had a lesson about total energy of a system, so I'm going to record this lesson so you are able to view it since there was a disruption in the lesson. So I'm going to explain about what is total energy of a system, delta U. So the definition, right? It is defined as the sum of kinetic energy, right, delta KE, and potential energy, delta PE, of a system. Okay, so this is the definition of internal energy. So we can put it in this equation: delta U equals to delta KE plus delta PE. That is the meaning of a system. For example, if you take gas, okay, for gas, right, the delta KE is very high, delta PE is very low. Okay, example, a gas. So we can say that the internal energy mainly depends on the KE rather than the potential energy. Okay, that's the meaning of it. If you take like a solid, the KE is a bit low, right? The potential energy is very high. That the reason because of the intermolecular forces, right? It's pretty high because the molecules are very near to one another and they have very strong attractive force. So the potential energy is very high. So we can say the internal energy very much depends on the potential energy, okay, rather than the kinetic energy, which is a bit low. So that is how we explain the sum of sum of total energy of a system. Okay, that's the meaning of it. Now, the other thing that we're going to look at is about the work done by a gas, right, or a system which is made of gas. That's what we're going to look at. For example, if you have a cylinder like this, okay, this is a cylinder, and this cylinder there is a piston, okay, and there's gas inside this cylinder, and this is a piston. And when you apply an external force on the system, right, the piston is now going to move through a distance of delta x. Okay, so that means this object is undergoing, this particular system or the gas is undergoing a compression. So the work done, delta W equals to F times delta X. So take note, the change here is because of the displacement, because from the definition of work is defined as the product of force and its displacement. You only will have work done if there is a displacement. Okay, so this is equation 1. So when this happens, the pressure inside this cylinder will increase. So the pressure equals to force per unit area. So force equals to the pressure times the area. This is equation 2. So I substitute, okay, substitute equation 2 into 1. So what I get, delta W equals to PA times delta X. So A times delta X will give you the change in the volume. So this is the volume of the cylinder. Okay, so therefore I can write it like this: P delta V, and the change in this delta is the same thing. Okay, that means it follows the change in delta V. There you go. Okay, but if you have change, let's say the pressure change, but no change in volume, no work done. Okay, no work done, because change in volume, delta V means there's a change in displacement, so there is a work done. Otherwise there is no work done. Right? Simple as that. Okay, that is number one. Number two, that you need to know, very important point, for compression of gas, delta V is decreasing, delta W is considered as a positive work. Okay, for expansion, right, of gas, delta V is increasing, is considered delta W minus. Okay, so work done, we use the term on the gas, work done on the gas, and this is work done by the gas. This is the term that we used. Okay, we will look at the examples when we discuss about the past paper question. Okay, the second part that we learned. Okay, the second part that we learn is about power. Okay, we learn about power. Power P. Okay, what is the definition? The power P is defined as the rate of work done, or sometimes it is defined as the rate of energy dissipated or changes. Okay, dissipated, that means energy produced also can. So power is the work done per unit time, or equals to the energy dissipated or changes per unit time. Okay, or the rate of work done. So W is joules, right, divided by time, so you get joules per second, or simply watts. W. That is the unit of power. Now from this equation, power equals to work over time, we know that, okay, from the equation of power equals to work over time. Okay, we know that work equals to the product of force and displacement. So we substitute this equation into here. We have power equals to the product of force and displacement divided by time, and velocity is equals to displacement over time. So we can represent power in this formula as well. Okay, so power equals to the product of force and the velocity. Right, so we'll continue this lesson in the next class. Thank you.